All right, so today we started talking about systems of equations. Okay, systems of equations is one of my favorite topics to teach, and overall, students generally grasp it pretty well. Okay, all right, so we're going to start today with two different types. The first one is going to be solving systems by graphing. Okay, so let's just do some vocab first. All right, a system of equations is two or more equations that have the same variables. Okay, so in general, we use y and x. Once we get to word problems, we'll use some letters that apply more to the word problem versus x and y. Graphically, the point xy is where the two lines intersect. Okay, and then algebraically the point xy is what makes both equations true. Okay, and we'll talk more about what all this means as we go through these. All right, so there are three different options that we have. The first that we have is intersecting lines. So we know what those look like. They just intersect somewhere, and wherever they intersect, that point in the middle is our solution with an x and a y value for our ordered pair. Okay, we also have the option to have parallel lines. So remember, parallel lines do not touch. So if the answer is where they intersect and these don't intersect, that means there's not an answer, which is no solution. You can write no solution, or this is our symbol for no solution. And then the third one that we have is where they are the same line. Okay, now I'm not going to technically, so if we've got the first line and then right on top of that would be your second line. Okay, so those intersect everywhere, which is infinitely many solutions. And we've talked about no solution and infinitely many solutions before, so those are not new to you. All right, so our steps that we're going to use for this is we always need to make sure we cannot graph until we are in slope-intercept form. So if your equations are not in slope-intercept form, we need to do that first. Then we're just going to graph the lines on the coordinate plane that's provided, and then we are going to identify our solutions. And it could be one or many, that's why I have that S there. Okay? All right, so let's just get started. Again, there's going to be two that are going to go on the same graph, and then we will talk about what happens with each one. Okay. All right. So the first one, I will always graph them in two different colors. So that way it's easy for you to see. Okay. All right. So the first one, we're going to start right here at -8 because they are already in slope-intercept form. So we're going to go -8, and then our slope is 1/1. So when we first started graphing equations, if you were to go back and look, I talked about wanting you to plot every point you could on that line. Okay. And the reason I do that, I told you back then that it didn't matter right now so much, but it would matter in the future. And today is the future. This is when it does matter. Give me just a second, trying to find a ruler so that my lines can be straight. I don't know why I don't even have a ruler. We'll make it work. Here we go. Okay. All right. So there's my first line. All right. My second line, y is again already by itself, so we're going to start at +1 and we're going to go down 2 and write 1. And you're going to see right there, that's what I care about, right there is where they intersect. And now I need to find that ordered pair. And that is 3, -5. Okay. All right, same thing for problem number 2. All right, so again, they are already in slope-intercept form, so we're going to start by graphing this one. So we're going to go up 9. and then I'm going to go up 1 and over 2. But see, I can't do a lot of those points, so I'm going to do the opposite, which is down 1 and left 2. Okay, and connect your dots. And then up 6. All right, so if I go down 1 and right 1, these points are never going to intersect with that green line. So I need to go in the opposite direction in order to intersect. And there's my intersection right there. Okay, so we're looking for this ordered pair right here, which is going to be -2, 8. Okay, so that is your answer. Where those lines intersect is our answer. Okay. All right, now number 3 is where we get started with ones that are not in slope-intercept form. So we've already done this before. Y'all know how to rearrange these. We're going to move our x. So it's going to be y equals positive 3x plus 8 for that one. And then for this one, same thing, move our x, and that's y equals positive x minus 2. So now we're going to graph those separately. All right, so I'm going to start at 8. I can't go up 3 and over 1, so I'm going to go down 3 and left 1 as many times as I can. Okay, make your little line. All right, and then for the other one, we're going to start at -2. And again, if I go up 1 and over 1, they don't appear to be intersecting, so I need to go in the opposite direction, and there's my intersection right there. Okay, so I need to find this ordered pair right here, which is -5, -7. Okay, for number 4, okay, top one is not in slope-intercept form, but the bottom one is, so I'm going to rearrange the top one. So I need to, let me work it out down here. I need to move my x, which makes it become negative. Then I'm going to divide everything by 2, which gives me y equals -1/2 x plus 2. Okay, so a couple of things. You notice that these two equations right here are the same. If you notice that initially, then you can go ahead and tell me that our answer is going to be infinitely many solutions because we have the same line. Okay, but maybe you didn't notice that. Okay, maybe you didn't catch on to that. So we're going to start with this one right here at up 2, and I'm going to go down 1 and right 2. Okay, and then I would connect my dots. I'm getting brave without my straight edge. Okay, and then I would do the same thing here. And then you're going to notice that these two lines are in fact one on top of the other, so they are the same line. Therefore, it was infinitely many solutions. Okay. All right, let's look at number 5. Again, the top one needs to be rearranged. So let's do that. Move that x and divide by 3. Okay. So now I'm going to start at -5 and go down 1 and right 3. Now, I don't know yet if that's enough. in terms of my points. I might have needed to go the other direction, but we'll just see what happens, okay? Now, this one's a little trickier. This is just Y. Remember, Y is a stick man with one leg, so he falls down, and he makes a horizontal line. So we're going to go down to -7, and we're going to draw a horizontal line through -7. And then right over here is where you're going to see that these 2 points intersect. 1, 2, 3, 4, 5, 6, and -7. All right, so take a second for number 6 and rearrange that bottom equation to get y by itself. The top one's already in the right order. The bottom one needs to be rearranged. Okay? All right, so if I graph the top one, I'm going to start at 5, and I'm going to go up 1 and over 1. Okay? So there we are. Try to keep that as in line as I can. All right. Then if I rewrite the bottom one, that x moves. Okay, so I'm going to go down 2 and then again up 1 and over 1. Now, you could have recognized right here, though, that your slopes were the same. So these lines are parallel. And remember, parallel lines never intersect, so our answer is no solution. All right, 2 more. Okay, both of these need to be rearranged. I'm going to trust that you can do that. So the top one is going to rearrange into y equals 3 over 5x plus 7. And this bottom one's going to rearrange into y equals -2x minus 6. So let's start with the top one. So we're going to start at 7. Up 3 and over 2. Oh, over 5, sorry. So down 3 and over 5. Okay, so there's that one. All right, and then this one starts at -6. Okay, again, if I keep going that way, I'm never going to intersect. So I need to go the other way, and there is my intersection. Right here. -5, 4. Okay. And then the last one, okay, this top line, X is a stick man with 2 legs, remember? So he stands tall. Okay, so we're going to go to -2 on the X axis and make a tall line, vertical. Okay. And then you need to rearrange number, or the second one. So again, I'm going to trust that y'all know how to do that. You move the 3, make it negative. So that's going to become a positive 3/2 X plus 9. I can't go up 3 and right 2, so I'm going to go down 3 and left 2. And immediately right there, y'all, you see the intersection at -2, 6. Okay, so that was the first part that we did today with just graphing. Okay. All right. So shift gears. We're going to go from graphing over to the start of elimination. Now remember, I told you we would get some more specific examples of this tomorrow and the next day. Okay, but basically our rules are such. Okay, the first thing we always want to do is make sure we're lined up with our x's, our y's, our equal sign, and our number. Okay, and then we are simply going to add these together. And we'll talk about all of this in more detail, like I said, tomorrow. But we're basically going to add these together. And when I add these together, you're going to notice that my y's cancel out. So I'm going to get negative 8x equals 8. And then we're just going to solve for whatever variable they have. Okay, so we've got x is negative 1. But there are two variables in my problem. So I need to find my other variable. So I'm going to go back in here and I'm going to plug negative 1 in for either x. Now I'm going to choose the bottom equation just because it's smaller numbers. We talked about it doesn't matter which one you choose, but it's smaller numbers. So if I'm using mental math, it's just less likely for me to make a mistake. And then from here, y'all, it is a two-step equation. I told you from the beginning this year that two-step equations are normally what everything's going to revert down to. But just like in our graphs, our answer has to be an ordered pair. And remember, for our ordered pair, x comes first and then y. So our answer here is going to be negative 1 and 12. If you were to graph these two, if you were to get y by itself in both of these and graph them, you would still get negative 1 and 12. Okay, do a couple more of these. And like I said, I'm not going to go into great detail because we'll do more of these in the following days. All right, so same thing. We're going to add. Our x's are going to cancel. They cancel because they're opposite signs, same number. Same thing up here. Opposite signs, same number. Okay, so add together. That gives me negative 32y equals negative 128. So we're going to divide by negative 32, and we're going to get that y is 4. Now, again, this time it was y. I'm going to plug into the bottom again, but I need to make sure that I plug that number in for y, not x. That's one of the most common mistakes kids make. And again, we're two-step in to the n. So x is 1, taking me to my ordered pair of 1 goes first and then 4. Even though you found 4 first, it's your y. Okay, let's do another one. Okay, add them together. Our y's cancel here, so that gives me negative 12x equals negative 24. So x is 2. Again, and now y'all, you can pick either equation. It just so happens that the bottom one seems to be the easiest for me so far, with the smaller numbers. So that's why I have done that. But you can pick either one, and as long as your math is correct, you'll get the right answer. So now we've got our x and our y, so it is an ordered pair 2, 3. All right, so I'm going to give you just a second to look through this one and see what you get as your answer. Same thing, you're adding them together, cancel out, and solve. All right, so if I add these together, my y's cancel, so I have 4x equals 12. So x is 3. Again, I would choose the bottom, and I'll show you in a second, though, that if you chose the top, you would get the same answer. So let me choose the top on this side just to show you. Okay, so I would do 3 times 3 minus y equals negative 1. and I would still get 10. So either way, as long as you do the math correctly, you do get the same answer when you plug in. So our ordered pair here is 3, 10. All right, so we're going to do one more of these because that's the last one on our notes yesterday or today that canceled out and was already lined up. And then we'll move tomorrow more into the ones that do not do that. Okay, so here we go. They already are lined up and they're already going to cancel. So x plus x is going to give me 2x. Negative 1 plus 9 is going to give me 8. And we're going to solve to get that x is 4. Actually, we did a couple more in class, so I'll do a few more of these that don't line up and can't. Well, they do line up, but they don't automatically cancel. Okay, so that one was 4, 5. And now if you go back to your instructions at the very beginning, we said the ordered pair, if you plugged it into both equations, it would make it true. So if you think about that, y'all, 4 minus 5 does give me negative 1 because x is 4 and y is 5, and 4 plus 5 gives me 9. I could go back and do that for every single one we've done, and it would make my equation true. All right, so now we start to where we've got a situation. They're still lined up, so that's good. What we don't have is they don't cancel. In other words, we don't have the same number with opposite signs like we have on every other one we've done. Same number, opposite signs. Same number, opposite signs, okay? We have opposite signs right here, a positive and a negative, but we don't have the same number. So I need to make them the same number, and I'm going to do that by multiplying by 10. Okay, so that makes this 10x plus 10y equals 90. The bottom equation is going to stay exactly the same. I didn't do anything to it, so it stays. Now we're going to add them just like we've been doing. So my x's will cancel, and I'll solve, and I get that y is 6. Now, when you go to plug back in here, don't go to the multiplied equation. Go back to your general equation, and I'm going to use the top one this time. Okay, so x plus y equals 9 and y is 6. So x equals 3. So our ordered pair is 3, 6. So that's as far as we got in class today. I'm going to do one more just to make sure we're kind of on track with what we were doing. Okay, but again, they're going to line up. They just do not automatically cancel yet. Okay, so like right here. I have opposite signs here, so I can make this bottom one what I need by multiplying everything down here by 2. So the top is going to stay the same. I didn't touch it. The bottom is going to become 8x minus 2y equals negative 6. All right, we're going to add these together and solve. So x is negative 2. Let's pick the top equation again this time. Haven't done many of the top equations. So x is negative 2 plus 2y equals negative 12. And again, remember, I went to the beginning one, not the one I multiplied. So our ordered pair would be negative 2, negative 5. Okay, so I'll stop there for today. We didn't do that one in class, but that just gives you another example. And we will get more into exactly what all we have to do and some more examples of those throughout the week. Okay, y'all have a great afternoon.